Okay, another recap starter. Pause the video and have a go at the 4 questions. Okay, hopefully you've had a chance to go at them. There's one more question on the next slide. Have a go at this one, please. Pause the video. Okay, let's have a go through them. Just turn my tablet back on. Okay, back online. So, factorizing. We want to, remember we got to multiply to make plus 48, and they need to add to make minus 14. So, let's have a look at our factors of 48. We've got 1 and 48, we've got 2 and 24, we've got 4 and 12, we've got 6 and 8. Thinking of how we can make 14 with these, well, these are going to make 49s, 47, so no. These are going to make 22s and 26s if we do any adds or subtracts. Both of these could work. Oh no, these ones can't work. That's going to make 8s and 16s. So it's pretty clear that our brackets are going to involve a 6 and an 8. The final step is just thinking, well, is this going to be a plus or a negative here, or is this going to be a plus or a negative here? Let's think about it logically. We want to make, when we multiply, positive 48. So we either need 2 positive numbers or 2 negative numbers, because that's how we multiply to make a positive. If we had 1 positive, 1 negative, we'd be making minus 48, which we don't want. And we want to make minus 14. So if we had plus 6, plus 8 in our brackets, that would make positive 14 when we add them together. So it's clear to me that we're going to need 2 negatives in there. Double check by expanding. So x squared minus 8x minus 6x and positive 48. These are going to join together to make minus 14x. So yep, I am happy that I've got that one right. Size of an interior angle of a regular decagon. A decagon is a 10-sided shape. Might not be one that you know, but may as well learn it now. So there's 2 ways we can do this. I'll see if I can go through both. So the first way is probably the more, I don't know, I'll go through the easier way first. We're going to find the exterior angle. It's not asked us to find the exterior angle, but it's easier if we just find the exterior angle. We find the exterior angle by doing the amount 360 divided by n, where that is the amount of sides. So in our case, it's going to be 360 divided by 10, which is 36 degrees. So that's an exterior angle, and we know that the exterior angle plus an interior angle of a shape equals 180, because if I'm going to draw a shape up here, doesn't matter what the shape is, the exterior angle is if I continue these lines over here. So my exterior angle is this, my exterior angle is there, and there. You can see if I continue this line, I'm making a straight line. So if I add my exterior and my interior together, I'm going to make 180 degrees, because it's just continuation of a straight line. So I know that 36 plus something equals to 180. So I can do 180 subtract 36. So my interior angle is 144 degrees. I mentioned about another method of doing it. Let's have a go at that one now on this side. So let me just fill that back in, that's the sides. So we've got our formula for an interior angle, where it is 180 n minus 2 all over n, where n again is the amount of sides. N minus 2 comes from, well, we can split that many triangles into it. So in a triangle, we can fit one triangle. In a four-sided shape, we can fit two triangles. In a five-sided shape, we can fit three triangles. And if you carried that on with a six-sided, seven-sided, the amount of sides you have, you can always fit two less triangles in there. So 3 sides, 1 triangle, 4 sides, 2 triangles, 5 sides, 3 triangles. That's where the 180 comes from. If we just did this top half of the formula, that would find the total interior angles of the shape. But because we know it's regular, we can divide it by how many angles there are, or how many sides there are. They're the same thing. And that should just give us 1. So if we do 180 times by 10 minus 2, which is 8, and divide by 10, so 180 times by 8, divide by 10, nice, it gives us exactly the same answer as I expected. So there's 2 ways of doing that. I think this way's easier. Depends if you can remember that or not. So our standard line is y equals mx plus c, where m is the gradient and c is the intercept with the y-axis. So if we were to draw a graph like this, that point there would be the plus c, and the gradient is how steep it is. This one's quite easy because we can just straight away tell, well, the gradient equals a half, and the y-intercept equals minus 3. It's just easy, nice easy. Y equals, no rearranging. Maybe we'll get some harder questions in later lessons. Okay, this one was a little bit harder. It's to do with similar triangles. So first of all, I'm going to draw my 2 triangles that I have out. So I'm going to draw my larger triangle, pretty badly, but that's going to be A, C, D, and I'm going to fill in my lengths I know. 12 and 4 makes 16, and this is going to be 9 plus something. We don't know what that something is yet, that length ED. And then I'm also going to draw my smaller triangle, which is ABE, which we don't know what that is. We know that this is 12, and we know that this is 9. Hopefully you can see that from the diagram. So with similar triangles, if we multiply one side by something, all the other sides follow the same suit. So if one side's double, the other triangle, all the sides are double. I'm going to look for a pair where I can find what we call a scale factor is. It's going to be these 2 sides. They match up. So I'm going to find my scale factor. By scale factor I just mean what we're going to multiply or divide by to find one side from another. I'm just going to do that by dividing them. Think about it with simple numbers. If this length here was 24, we would divide 24 by 12 and we'd get 2, which is clear to see that it's times 2, it's double. In this case, it's not going to be as easy. It's going to be 4/3. So that's our scale factor. If we want to get from the small triangle to the large triangle, we're going to times by 4/3. And if we want to get from the large triangle to the small triangle, we're going to divide by 4/3. So moving from this side to this side, so this would be length BE, we're going to do 9 divided by 4/3, which is 9 divided by 4/3, not a very nice number, but 6.75 meters. So that's going to be our answer for this one. And if we want to find the length of DE, which is going to be part of this, so E is going to be around here, DE is going to actually be this box here, because we'll have 9 of AE, and then DE will be the extra bit we add on. So to find the full length of that, we're going to have to do 9 times by 4/3, which is 12. So the full length of this is 12. However, we're not asked for that, we're just asked for the small section of DE, so that's going to be 12 subtract 9, which gives me 3 meters. So here, just that little section, 12 would have been this whole thing.